Hello, and welcome to your OSL, I almost said ULI 101 there, OSL640 Week 10 lecture. This will be the first of two videos, and I'm going to warn you in advance, these are going to be a little bit longer than normal, just because there's a lot of content to get through. I mean, there's 51 slides, as you can see if you happen to look at the top corner there. So, if you want to pause, go get a drink, get comfy, feel free to do so. But yeah, sit in and get ready for a full bit. We're going to look at bash scripting today, which is a very, very useful skill. And that's part of the reason why it's so long. There's a lot of content, and there's a bunch of example scripts we're going to write. So in lesson 1, we're going to look through what shell scripts are and some things that you should think about when creating them. Some basic things that we use in shell scripts like comments, the echo command, the shebang line, what they are, how they work, and if you don't understand what those are now, don't worry, it's not a big deal. And we're going to look at how to create and run shell scripts. Pretty straightforward. We're also going to look at some shell variables. And all of this maps to your Week 10 tutorial, Investigation 1, and your review questions, Part A. So note there's Part A and Part B for the review questions this week. It's structured slightly differently than the rest. Part A 1 to 3, and Part B there's a walkthrough. So, with all that in mind, what is a shell script? It's a good question. A shell script is a computer program that's designed to be run by the Unix shell, which we've been interacting with all semester. That's your command line interpreter, right? Typically, you do things like manipulating files, executing programs, printing text, and you tend to use shell scripting from an administrative standpoint to automate repetitive tasks, which I think we're going to look at in the slides, but if not, we're going to touch on that. Oh, look right there. So why do we create them? Well, to automate executing commonly issued commands, shell operations. You can use loops, you can use logic, you can use math calculations, you can do all kinds of cool things that you can't do normally from the command line on their own. And some of the examples we'll look at may seem silly until you think about like the ways that you can take that knowledge and apply it in a different situation to solve a problem. And that's what shell scripting is, in its essence, is solving problems for a system administrator. Before you create a shell script, you should think about what you're actually trying to do and maybe plan out your steps a little bit. And these sequence of these steps can be then used to create your script. So once you've sort of planned things out and you've thought about what it is you're going to try to accomplish, you need to create your shell script using a text editor. That's partially why we looked at text editors earlier in the semester. This should be a good refresher with some of that. You're going to want to avoid using file names that are the same as existing commands. So you wouldn't want to create a shell script called ls, for example. So you can use a handy utility in Linux, a handy command called which, and it will tell you if that file name that you're thinking about using for your shell script exists within the system as a command. And if it doesn't, boom, you're good to go, you can use it. You may also want to add the bash extension, since we're dealing with bash shell in this particular example today. But any sort of extension at the end of your shell script, just to identify to the user, you, and anybody else on the system who has access to run your script, what sort of script it is you're running. This isn't necessary for the file system to tell what sort of file it is, as we previously discussed. When you're creating shell scripts, it's useful, first of all, to comment them. And you can do that by using the pound or hashtag symbol in front of a line of text. And what comments do, and you should have learned a bit about this in your Introduction to Programming class, is you can add some human readable information within a comment that describes what it is you're trying to do in the following line. And that way, if somebody else is looking at this later, or even you're looking at this 3-6 months from now, even a week from now, depending on how good your memory is, trying to figure out what exactly it is you were trying to do, because either it's not working or you found that it's causing an unintended error and you're trying to fix that, it makes it a little bit easier to figure out what's actually trying to be done. So they're a good thing to add in. And there's a special type of comment that goes at the top of your shell script that specifies what shell the script should be run in. And that's called the shebang line. There's different ones for different languages that we deal with. They always begin with pound exclamation mark, and then a path to the interpreter. So if we're using bash, which we are, it's pound exclamation mark /bin/bash. If you're using Python, there's a shebang line for that. If you're using Perl, there's a shebang line for that. And there's other shell scripting environments, such as Corn Shell, that exist in certain Unix environments and Linux environments that you can use as well. So this is not unique to bash by any means. Aside from this one, comments are ignored by the interpreter. That code is not executed. But the shebang line must be the first line, and it has to be at the beginning of the line. You can't have a space in front of that, or it'll cause an issue. The Linux shell has evolved over, a long time, like 50 years, when you think about it. So the use of the shebang line forces the shell, the shell script to run in a specific shell, which could prevent errors if you're trying to run it in an older shell that doesn't recognize newer features, so on and so forth. And you could always use the which command to determine what the path name or full path name of the shell should be. So if you execute which bash, which I think on matrix this gives you a different result, you should see /bin/bash, and that's what your shebang line should be. If you're programming in Python, which Python will give you the full path name to Python on the system. One of the first things we do when we're writing shell scripts, and one of the simplest things to learn, is how to display text to the user. It's particularly useful to display meaningful messages, either with some information that you've processed, or in case there's an error, right? You want to tell your user exactly what's gone on and how to fix it, and how to rerun the script with that information in mind. You don't just want to exit and not give a message. So we often commonly use the echo command, which we've looked at within shell scripts to print out text in the terminal. And generally, any text that you want to echo out, you're going to use double quotes around. That way, it will allow shell expansion on variables, but it will suppress a whole bunch of other things and prevent problems with special characters, and it's just a good practice. So if you're going to use echo to display things, just stick double quotes around it. Something to keep in mind. So to run a shell script, you have to do a couple extra steps before you actually execute a shell script. First of all, you have to give it execute permissions, at least for your user. And you can do this using the chmod command. So chmod u + x, and the name of your script. Also, commonly, people just, and I do this a lot, chmod + x. We'll just give everybody execute permissions. It's the kind of quick, lazy way of doing things. Might not be the most secure, but it does what I need 90% of the time, so that's what I do. And then once you've done that, you can run your shell script by issuing the shell script's path name using a relative, absolute, or relative to home path. So if we're going to do relative, dot slash, and the name of the script. Absolute, of course, this is an absolute path for something that's in home username directory. And relative to home, tilde, this here. And you've been doing these all semester, whether you've realized it or not, by running these check scripts that exist. They're just bash scripts that you're executing on Matrix. So, with all that in mind, I know that's a lot to process. Let's actually see some of it in action. We're going to write a quick shell script. It's going to clear the screen and then display all of the users that are currently logged into the system. So I'm going to pull this to the side. Make sure I'm logged into Matrix. Oh, look at that. I am. That's awesome. I'm in my demo directory. I got a bunch of things here. None of them are shell scripts, so that's fine. I'm going to create a new file. I'm going to call this one who's on. And I'm not going to call it with the .bash extension. You can, you don't have to. It's a good idea. I generally don't. Just throwing it out there. So the first line we need here, and I'm going to have a comment block at the top of each of these, because it's a useful thing to do, and I'm going to show you why. It's just a good practice. I like demonstrating best practices. So I'm using Vi for this, of course. And I'm going to set... now before I get too carried away, I'm just going to save this and go back in. And look at that, I got syntax highlighting in Vi. That's why I used Vi and not nano. So back in the insert mode. Author. Whoops. My name and my email. This is again just a best practice. Just in case, you know, if you actually have a script that you think is useful, you're going to share it on the internet somewhere, either through GitHub or start a wiki or a blog or something. It's useful if somebody else is executing your script and finds a problem or has some feedback like, hey, I did this cool thing with your script, maybe you want to incorporate it or not. Having your contact information is useful. Created today. Oops, 15th, 2021. Its purpose. Always a good thing to throw up front just so people, before they get into the guts of your script, know what's going on. So we're going to clear the screen and list all users currently logged in. Usage /who's on. And if I had error codes, which we're not dealing with error codes and exits this week, but if I did, I would include a block up here as well about what that is. And I always like to leave just a blank one at the end, just to, I don't know, it looks better, I think. Sorry, I had to cough, and I think I paused there to do it in time, but if I didn't, I apologize. So what are we going to do in our script? We're going to clear the screen, and we're going to display all users logged into the system. So these are what I was talking about throwing comments in there to make it clear what you're trying to do. So how do we clear the screen? Well, that's simple. Clear. And how do we display all the users currently logged in? Who? And we're done. Save it. Give it execute permission. And then if we do an ls, we should see it here, and look at that. It's green, so that means it will execute and run it. And there we go. Pretty awesome. I cleared the screen, and it ran. I'm just going to clear the screen again. Your simplest shell scripts tend to start like really simple, just the commands that you would execute from the command line in a script. Like that's it. You put them into a file so you can run it and walk away and go get a coffee or go to the washroom or go do something. That's how I first learned shell scripting. I was in my second semester, and at the end of every lab we had to back up our virtual machines. And I found this always to be a kind of time-consuming and boring task because you had to execute a command and wait a few minutes, and then execute another command and wait a few minutes. And I thought, you know what? Well, actually, I called the lab assistant over and I asked him, but I was thinking to myself, if there was a way I could speed this up so I could, sit around and take notes or do something else while this process was happening, that would be something that I want to learn. And that's how I first learned bash scripting. One of the lab assistants showed me how to write a bash script. Just a couple quick little pieces of advice, and I took the commands that I was executing from the command line, I threw them into a script file, I made it executable, and I executed that and locked my screen and went and got a coffee, used the washroom, got some water, did something else while my backups were running, because it would take about 5 minutes per virtual machine, and it was 3 virtual machines, so there's 15 minutes where I was just sitting there that I could go do something else. Just freed up my time. It's useful. Repetitive tasks that you're going to do a lot, automating them is your friend, especially as a future sysadmin. We tend to like to automate everything. Don't go too crazy with that, though. So when we move past our simple shell scripts into some more complex stuff, one of the easy things that we can add that will take our fairly simple shell script and make it a little bit more versatile, a little more portable to different systems or scenarios or situations. I guess scenarios and situations are kind of the same thing, is using a variable. And you should have learned about this in your Introduction to Programming class. Variables are used to store information that can then be referenced and manipulated later within the program. They also give you a way of labeling data with a descriptive name so programs can understand a little bit more clearly what's going on. You can kind of think of them, I guess a useful way of thinking them is they're containers to hold information. It's just a name that's going to hold that information in it. Its entire purpose is to label and store the data, which can then be used later in your program. And they work more or less the same in every programming language. So everything that you know from Python more or less applies here. It's just the way that we deal with them is a little bit different. The syntax is a bit different. So variables within shell scripting, there's 2 types of variables that we can use. There's system variables or shell variables. So these are environmental variables that we can use and pull from the operating system itself that are stored within the shell by default. And we're going to look at some of these that are kind of useful. Outside of that, you have user-created variables. So these are variable names that you, the programmer or the user, create for use within the shell script. User-created variables can be any sequence of letters and numbers, but it cannot begin with a number. And you can't have spaces. So you should avoid any other characters too. If you want to have a look at your shell variables, your environmental variables, then there's a few below, and you can have a look at these by running the set command and piping it to more. So PS1 is your primary shell prompt. And you can refer to this with a $sign in front of it. We're going to look at that in a little bit. You can refer to all of these with a $sign in front of them. PWD is your present working directory, and it's not just your present working directory, it's an absolute path to it. Home contains an absolute path to the user's home directory. Path gives you a list of directories where commands and programs are stored, and this is where bash is going to look when you try to execute a command, and it will sequentially loop through these until it finds the command and executes it. Host contains the host name of the computer. User contains the user that is logged in, and shell contains the name or type of the current shell that is used. If you want to pull information out of a variable name, you just put a $ in front of it. And what that $ means is the value of whatever the name or variable name that comes afterwards. So if you want the current directory from the global variable, my current location is $PWD. That means the value of PWD, all in caps, so we know it's a global variable, and that will expand, even if in the double quotes, to an absolute path to your home directory or present working directory. User, right here, again, the $ in front, so we know it's the value of user. While doing a who and then piping for a grep to user, we're looking for just the current user, right? Echo host is going to give you the host name from a global variable again, the value of host name global variable, which should expand to something to the equivalent of matrix. It's going to be a little bit different, but not exactly different. So creating user-defined variables, they're simply just they're variables we create to store information within our shell script that we can then use later in our shell script and reference. You can assign values to variables and create them by issuing the name that you want to create the variable, an equal sign, and its value without spaces. A note: if the value contains spaces or tabs, you should have double quotes around it. If there's spaces on either side of this, it's not going to work. And an interesting thing about bash is you can do these literally anywhere in the bash script, and you don't have to define their type like you do in some other programming languages. You just create it, and bash will use it in the context that you're trying to use it. It'll try to figure out what type of data is in there. So they're dynamically typed. They're not statically typed. If you want to remove a variable, you want to clear the contents later, just because you don't want anybody accessing that data, or you want to use it again or something, and you just want to make sure it's gone, you can do this in one of two ways. You can assign the variable name to equal nothing, just stop there, and it will wipe the contents. Or you can use the command unset. So unset, and then the variable name will clear it. It'll remove it from memory. For prompting user for information, which we tend to do when we're first learning shell scripting, and it can be a useful thing in future more advanced shell scripts, we tend to use the read command. Read-p, so this will prompt the user for input, and it will wait. You can give them some text here, so whatever you put in the double quotes, that will display on the screen. That's your prompt. And whatever you put after the double quote with the after the space here, so age, that's the name of the variable that the information is going to be assigned into. So read-p, your prompt, a variable name, which doesn't have to be created prior to this, and then you can do things like echo it back to them, or do some math and echo it back to them. We're totally going to do these things today, so don't be too afraid. If you've created some special variables that are like super important to your shell script working, you might want to consider using the read-only keyword in front of it. And what this will do is it will prevent the user from changing the values of the variable while that shell script is running or during the duration of the shell session. So you just put read only in front of the variable name before you assign it, and it's done. It will be a read only variable. You can't rename it. So again, with all that in mind, we're going to create two shell scripts here. We're going to write a quick script. The first one that's going to print out my username is, and then pull that information from a global variable, an environmental variable, or environment variable. And then our second one here, we're going to have the user enter their full name and age, so we're going to prompt them for information, and then we're going to display it back to them. They seem like silly, simple examples, but we need to start simple. We'll build up to more complicated stuff. Don't worry. Start simple. Anytime you're learning anything, start simple. So, back over to my matrix session. And I'm going to create this next one. I'm going to call it who. So, vi who. Bin bash. I'm going to do all the normal stuff that I did before. Author. Purpose. Whoops, that should have a... That's going to cause issues. So we're just going to simply echo, because we're not prompting for any information. We're pulling this from a global variable. My username is $$ user, right? We're using the global variable user, and we want its value, the value of user. I'm going to save this. I'm going to give it execute permission. And I'm going to run it. And there we go. And I probably should have cleared the screen first in my script too. I didn't. That's fine. I'm going to show you the contents again on the screen. Actually, I'll do it in Vi so we get our syntax highlighting. Look at that. So if you're watching the video again, you want to pause, have a look, feel free to do so. Now we're going to do our second task here. We're going to prompt the user for some information, and we're going to give it back to them. I called this one age, and I'm working off notes. I worked all these out ahead of time, so we didn't have to do it on the fly. It makes the demo portion in a video go a bit faster. We need our shebang line. I wanted our syntax highlighting right away. I could have just done that a different way, but is what it is. Author, my name again. I'll also put my Gmail address. Created. Purpose. Prompt the user for information, then display it. Usage. And of course, if I had error codes, I would add them here. I'm going to read. Enter your full name. And I suppose I should have capitalized those, so let's do that. Now I'm going to want to put a space at the end of this because that will display in our prompt. If I don't do this, then where the information is read into and the colon, there will be no space there. And where are we going to store this? We're going to store this into name. We're going to prompt for a second piece of information, their age. enter your age, and we're going to store this into age, and then echo out, hello, my name is name, so $name because we want the value of name, and I am age years old. And let's give that a go. So what do? We give it execute with permission, right? With chmod, and then /age. So enter my name, enter my age. There we go. I'm going to open that up again, just so you can pause, have a look at the source code if you need it. Move that cursor so you can actually see the full command there. And that's going to bring us to the end of our first video. So, for getting practice with this stuff, work through your Week 10 tutorial, Investigations 1 and 2, and your practice questions, Part A, 1 to 3, and Part B, the first walkthrough there. And I will see you in the next video. So, take care, be safe, I'll see you in a couple minutes, or at a later date depending on when you're watching these. Bye for now. See you in the next video.